So today we're going to be looking at definite integration, but before we do that, let's make sure our indefinite integration and what we covered last lesson is all up to scratch. So have a go at this starter. So for this final example, I've got a single power of x on the bottom, so that's like having the integral of 1 over x dx, which I know is ln x. So I know it's going to be something like a half ln 2x plus 1 plus c. But if I wasn't sure, I could check that, so I'm going to write check. So if I have y is equal to a half ln 2x plus 1, if I differentiate that, I want to get my question, so I want to get 1 over 2x plus 1. I need to differentiate that using the chain rule. So I write out the chain rule. So I know I can rewrite my y as y equals a half ln u, because it's a composite function. So u is 2x plus 1. And now I've got dy by du is 1 over 2u. And I've got du by dx. It's just 2. So if I want dy by dx, I've got dy by du times du by dx, which is 2 times 1 over 2u, which is just 1 over u, which is 1 over 2x plus 1. And I scroll back up. That's what I was integrating, so I know I was right. On to definite integrals. So a definite integral is an integral between an upper and lower limit that gives a numerical answer. So all the integration we've been doing so far is called indefinite integration. Indefinite integration, we're going to write it with our integration symbol, but we've got these two limits, a and b. And these are the upper limit and lower limit of the integration. B being the upper limit at the top and a being the lower limit at the bottom. The geometrical significance of that is that the definite integral of f of x between b and a is the area enclosed by the graph of y equals f of x and the lines x equal a and x equals b. We're going to talk more about that next lesson. So how do we evaluate definite integrals? So what I need to do is I'm going to perform my indefinite integration on the function first, and then write these square brackets around it with my limits. Then to apply my limits, what I'm going to do is I'm going to substitute in my upper limit to the function, and then I'm going to take away the function of the lower limit. So I have the integrated function of b minus the integrated function of a. I think the easiest way to understand this is through examples. So let's have a go at some examples. So just watch me do one first. So I'm going to write my square brackets. If I integrate x squared, I need to increase the power by 1, divide by the new power. And in this case, we don't write plus c. That's because when we do our difference, the c's are going to cancel out, so we don't need to worry about them. So now what I do is I replace x with the upper limit first, and then I take away the function with the lower limit. So if I put that in my calculator, I end up with 19/3. Let's look at this second example. If you're feeling confident, pause the video and have a go yourself first. So I need to integrate first. So if I integrate this, I'm going to have increase the power by 1, divide by the new power. So x to the 4 divided by 4 minus 2x squared over 2 between the limits of 4 and 2. Just going to simplify that. Then I'm going to apply my limits. So I'm going to have this for my first part. Then I need to take away the whole of the function with the lower limit. Pop that in my calculator. I end up with 48. Final example. So have a go at this example first. So pause the video. So the first thing I'm going to do is make sure what I'm integrating is in the form ax to the n. So this is the same as 3x to the minus a half. Then I'm going to do my indefinite integration part. So I increase the power by 1, divide by the new power. Simplify that. I can rewrite that as so, because I'm looking for the exact value. So I end up with 6 root 9 minus 6 root 8, which is going to be 6 times 3 minus 6 times 2 root 2, which is equal to 18 minus 12 root 2. So the classroom works on OneNote. Give it a go and let me know if you have any questions.